So here I am back again. It's me, Georgianne, proceeding to the next chapter in your book, which is chapter 10, C Structures, Unions, Bit Manipulation, and Enumerations. That sounds like a lot of topics, so I'm going to break it up into smaller YouTubes. So this lecture is going to be about structures. So a structure is a collection of data, but the data types can be different types of data. And you can compare that to an array. An array is a collection of data, but all the data types are the same. So a structure is defined or declared using the keyword struct. There it is, S-T-R-U-C-T. And that enables you to define this collection of data types, which you can have a lot of flexibility with. So the first example I'm going to do is going to be different than your books because the books used a pointer, and I know pointers are a difficult topic, so I'm going to do a simpler example first. So I'm going to define a structure called a hurricane, which is a new data type. So a hurricane has a lot of different things that can describe it. It can have a name, it can have a category, it can have the year that it occurred, and so that's what we'll use to define our structure called a hurricane. So this is how you define it with the keyword struct, and it's called a hurricane. That's our tag name it's called. And then you set up sort of its what kind of types of data are going to be included in this structure. So I'll define that it has a name. I'll give 10 spaces for the name. It has a year and it has a category, which are both ints. So this defines our structure. Now, if you want to declare and use your structure, like declare and use any other type of data that you might in your program, you of course have to declare and initialize it. So I have a hurricane 1, and I declare it by saying it's a structure of type hurricane, and its name is H1, and these are its properties on the right hand side. So its name is Camille, the year is 1969, it was a category 5. So now I've actually made a particular hurricane right here, particular hurricane H1. In the previous slide, I defined what the structure consists of, but there's no specific details. Now I'm giving properties to these particular data types, or giving values to it for a particular hurricane H1. Oops, I see a mistake. Now I can use it, that should say H2 there, so it's hurricane 2. So I can use it in my program, for example, to print out the values of the different variables. This should say H1.name, H1, or either make that H2 or make these H1 down here. It's a mistake. So I can use a hurricane H2.name, hurricane H2.year, hurricane H2.category, and it will print out the corresponding results. But notice how I use it. So it's so I fixed that. So you access the data in your structure by, this is the member name. So H2 is a hurricane. And its member name is H2. And then the next part, if you want to access some variable that's associated with the member name, you have the variable name. So that's the variable name here. The period in between, the period that's there, let's say variable name. The period is there, actually has a name also, and it's called the member selection operator. So I'll write that down, member selection operator, because it allows you to select a member. The member is H2, and you can do a selection of one of the properties of the member. So it's a member selection operator. That's what the period is. So that's how you access the members or use the members and the different properties, variables associated with them when you're using a structure. And one little other side note, when you are using or declaring your structure here, it is illegal to have your structure tag or your tag name also be struct, because struct is a keyword. So I can't say struct. That would be illegal. So things you can do with structures. Whoops. Oh, assign. So I had one example of assigning members, declaring a new type of hurricane. Here I had an example, and I also had an example of assigning the values to it. So you can also do it this way. So h2.name equals, and it turns out for this, the way I've declared it, this doesn't work, so I have a no right here. But I can do string copy h2.name is Hugo, and it will put the word Hugo into the string. I can continue to assign members or variables. h2.year equals 1990, h2.category equals 4, and then when I print them all out again, it works. I can do things with structures. I can make one structure equal to another structure. Here I've declared a structure hurricane H1, and I've made H1 equal to H2. You cannot compare structures with rational operators, at least. You can compare members of the structure, though. So I can say if h2.year equals h1.year, then do something with the if statement. So I can compare the members of the structure, but I can't exactly compare. I cannot compare structures. I can even use functions with structures. So here I've created a simple function. It says print hurricane, and it's expecting to get a structure, a hurricane structure passed to it, and this is how you would declare it. And then I can say this function just prints h.name and prints h.year, h.category. So here I've created a function who's expecting to have an entire structure passed to the argument of the function. Oh, I also should point out, because this is going to happen to somebody, I'm sure, defining the structure of a hurricane. So when you're first defining your structure, before you fill in any of the member information, note that even though that there's a semicolon right here, so a lot of times that gets missed. So just watch for that. Now let's look at your book examples, which are based on deck of cards and playing games with deck of cards. It's going to make a structure called a card, and then of course you can guess what the properties of the card might be. It would be its face and its suite. So a suite would be the shapes, the heart, diamond, spades down here, and then the value would be ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the properties of the card. So let's look at defining a structure, a card structure definition. So this is the structure definition right here. The structure tag, just to review you, the structure tag is card. So card is the structure tag. The structure type is a struct card. This is structure type is struct card. And the structure's members are face and suite. Those are the members. And the members type are of type, this is the type of the members. So the structure's members are of type pointer to a character. And the members are face and suite, or suit. Some people say suit, some people say suite. Structure type is a struct card. The structure tag is card. So here's how we define our card structure. The interesting thing here to me, I thought, was that we were using a pointer. So this is a pointer to a collection of characters, and so we're pointing to the beginning of that collection of characters. So now that we've defined our structure, and notice I can put it like a where I would put my function prototypes outside of main. I can also put it inside of main in this simple program. It wouldn't matter. In your textbook example, it's outside of main. So I've defined, did my structure definition right here, my card structure definition. And now let's look at the main program and see how it uses it. So the first thing I do is I define one structure card variable. That's a good way to put it. So I called it a card. So I defined one card and I called it a card. It is of type structure card. So I declared it right there in the program, and now I'm going to assign some values to its members. So acard.face gets ace, and acard.suite is a spade. So it's an ace of spades card. So this next step, I'm assigning the address of a card to a pointer, so card pointer. So this is similar to all the other assigning addresses to pointers that we've done to this point, which is fine. So I have now a pointer to the address of a card. And how are we going to use it? So there's something different in how we are going to use it. So there's a nice print start statement, acard.face, which is fine. It'll print ace, and then together with another little piece of character string here, and then acard.suite. Now that's pretty easy to see because we're already used to using the dot operator, but there's a new operator here also called an arrow operator, and it's associated with when you're using a pointer. So when you're not using a pointer, you'll use the dot operator. If you're using a pointer, you're going to use the arrow operator. This section right here is really 3 different ways of saying the same thing. So in each one of these cases, it's going to print out. The first one will print out, this section will print out ace of spades. Is that what I had? Ace of spades, yeah. This will also print out ace of spades, and this will also print out ace of spades. In one case, I'm using the arrow operator. Next place I'm using, this case I'm using the dot operator, and this case I'm using the dot operator. But notice I can do a dereferencer operation right here. So card pointer, what am I pointing to? That star means what am I pointing to, and I'm pointing to a card, and I'm getting its property of face. So let me make a few notes here. Whoops. I personally think that the terminology gets confusing in the structure, especially when I'm showing you 3 different ways of printing ace of spades. So I wrote a few notes here. I hope you can read them. But I also suggest that you do the same with the terminology, because otherwise it's very hard to read your textbook if you don't have the terminology. So some of it is in the comments here. So this is one structure card variable whose tag is a card. The tag is a card. The tag is like its name, but when we're dealing with a structure, then it's called a tag. And then down here, when we started printing the results out, I wrote that again. A card is a structure tag, and then there's a dot operator, and face is sometimes the textbook says it's the member name, or it's also called the structure variable name. But remember, name is a member of the structure card. So those are the members, are also called the variables. So then I had my 3 different ways of printing it. First one was the structure tag dot member name. This next way was using the address of structure, address of the structure whose tag is a card. And that was with card pointer, because remember, card pointer is the address to a card. So this is the address of the structure whose tag is a card. And then we have a structure pointer or a structure pointer operator. And then again, name is still a structure variable name, or also called a member name. Do the same thing here. Card pointer is still the address of a structure whose tag is a card. And then the third way that we do it, again pointing out the terminology, is by using the dereference operator to the pointer. So now I'm saying I'm dereferencing card pointer, so that means I'm actually pointing to the thing that's really stored there. So that would be pointing to a card, or actually at a card, the thing that's at a card, and getting the face member. So terminology is kind of a killer. Work on the terminology. So let's look at another new feature before we get into the big card program. This use of a keyword type def. There it is, type def. It's a type definition. So it provides a way to create synonyms or aliases for previously defined data types. And I'll tell you what I mean right here. So we created a structure called card, which we've been using as our example. And then I have the statement here, type def struct card. This is the same structure tag as right here. These two cards are the same right here. And then I have this word with a capital C, a new word thing. This is our alias that we're creating with a capital C. What it's allowing you to do is declare a new card in your program without having to use the keyword struct. In other words, card, right here with a capital C, is an alias or a synonym for typing struct card when you are creating a new card structure in your program. So I'll give you an example right here. Back on the example that we've been looking at, here you defined one structure, card structure called a card, and you assigned some values to it. But down here at the bottom, I did a type def and made an alias with a capital C called card. And now I can declare a new card. I called it B card just by saying the word card, B card, and it takes away the need for having to put the word struct card before that. So now I've created a new card called B card, and I assigned values to its members in one line. I could have done it like I did it up here, but I actually did it in one line. So okay, that just helps make some of our programs simpler going forward, or at least simpler to look at. So far I've declared two cards. One of them was called A card. It was Ace of Spades, and the next one was called B card, and I think what did I say? It was a Two of Spades, I think, in the last program. Well, you know, there's 52 cards in a deck. How am I going to have 52 cards? So I can declare an array of cards if I want. So here I defined my structure card. It's this card structure definition. Here I did my alias. I did a type def so that I don't have to write structure card all the time. And down here I've defined an array of cards called deck. So it's an array. Deck has 52 elements because of this defined structure up here, and it's of type card, but card is an alias. It's actually I could have said struct little card with a little c and then deck cards, and it would have been the same thing. So this is a nice shortcut way of doing it. One other little convention, if you will. When I do my card structure definition, it's with a lowercase c, like we're used to doing with variable names. But then when I do a type def, I changed it to a capital C. I either had to have a new name or something, but a convention is to use now with a type def, with our aliases, to use the capital with the same name. That's a common style, programming style. So I'm actually working up to doing the example on called Figure 10.3 on page 412 of your book, which is a program that creates all of the cards in a deck of cards and shuffles them. So it's a dealing algorithm, but it's a sophisticated program. So I'm working up towards it as I'm going through these examples. Okay, so right now we've declared an array of card structures, and it's time to fill the deck, fill up the values. So to make the deck of cards, these were the values that the cards would have, like, okay, ace, deuce. Okay, fine, deuce is for 2, 3, 4, 5, 6, 7, 8, all the way up to a king. So there are 13 values here. So I created those 13 values, or your author did, by initialing an array of pointers. So I have an array of pointers. So I have a pointer to ace, a pointer to deuce, a pointer to 3, a pointer to 4, and it's an array of pointers. That's what it is. And then here's another array of pointers for the card suit. So it's an array of pointers because there's a pointer to hearts, a pointer to diamonds, a pointer to clubs, a pointer to spades. Now comes the fun of making the 52 cards. And again, the author's program is a little sophisticated, so that's why I'm spending time going over it. So this is a function that puts these strings into the card structures. So let's take a look at it and figure out actually what's happening in this program. So his function is called fill deck. So you're really creating the 52 cards. You have it's expecting a card structure. It's expecting a pointer to an array. Didn't we just create that? And a pointer to another array called suite, an array called face, an array called suite. So that's what the function is expecting to get. Let's look at how it does it. So here's loop through the deck and create all the cards. So basically you're going to pass deck into this function, and you're going to loop through the deck and assign a value to each face and assign a value for each suite. And there are 52 cards. At the beginning of the program, there's a place where there's some constants declared, but there at the beginning there's a define statement. So there are 52 cards, and there are 13 faces, and that was at the beginning of the program. I could show you real quick. So at the beginning of the program, we define cards to be 52 and faces to be 13. So I'm working through parts of this program. Okay, so let's look at how my arrays, my pointer to these arrays of faces and suites, are going to fill in and make my 52 cards. The first thing I say, I'm going to go through, there's 52 elements, 0 through 51. So the first card in the deck, the first card structure in the deck, so it's a card structure. So it's an array of structures that we're working with called deck. And there are 52 card structures in the deck. So I'm going to take the first card structure here, element 0, and its face variable is going to get assigned something that's pointed to right here from an array of pointers to an array of pointers that have values of the card faces. And then what's happening here? What is happening right here? I'm saying get face element something. So what is actually happening here? Remember, I is going between 0 and 51 for the 52 cards. So let me just look at that for a minute. I% faces. So what's happening? So the first time I go through this for loop, I is 0. So I'm doing 0% 13. It's not a percent, it's the remainder operator. So what's 0, the remainder of 0 divided by 13? The result of that division is 0, and the remainder is 0. So the remainder is 0. So the value of that is 0. So now I go through the loop a second time, 1% 13, remainder operator, and the value of that will be 1, because 1 divided by 13 is 0 times, but there's a remainder of 1. And I keep going down through it. For example, when I hit 12, 12 divided by 12% 13, remainder operator, is 12 divided by 13, which goes 0 times remainder 12. And then I hit 13%, 13, and 13 divided by 13 is 1 with a remainder of 0. And you can see I'll go all the way down till I get to 51, because that's what my for loop says. 51% 13 is going to go 3 times with a remainder of 12. So you can see this particular line of code right here, what it's doing. It's saying that dec element 0, its value for face is going to get, and I'm going to go over to the face array that I pointed to right here, array of pointers. Actually, it's an array of pointers, and I'm going to get element what? 0% 13 on the first pass is going to be a 0. So what will happen, going back to the previous one, look at face. So it's going to get assigned ace, because element 0, the first pointer points to ace. The 0th pointer, I should say, points to ace. Oops. So my first card structure in dec, my dec has 52 card structures in it, but my first card structure, its face value is going to get ace. Likewise, my 0th card structure, its suite, or suit, however you say that word, is going to get what? It's going to get the array of pointers to suite or suit. Some people say I guess I mix it up, and it's going to get element what? 0 divided by 13. So it's going to get element 0. So let's look at what that element is doing for the suites. So for the fun of it, element, what's the element? What's this counting? We see right now that this first one, this thing that's declaring what element to get, is basically going 0 to 12 4 times as it goes through this loop. What is this one doing 4 times? This one is getting, these are integers, right? 0 divided by 13 is an integer. What is that going to return? It's going to return 0. And when I is 1, it's going to return 0. When I is 2, it's going to return 0. When I is 3, it's going to be a 0. It's going to calculate to 0. All the way up until the magic value of I equals 13, and then we'll get a 1. And then I equals 26, we'll get a 2 here. And and when I equals 27, it will be 2. When I equals 28, it will be 2. 29, it will be 2. So you can see what's happening here. I probably wouldn't have thought of this if I was programming it myself. I probably would have done a little bit of a different calculation, but hey, it works. So let me just, I'll write that one down just so it's so we're complete here. So I divided by faces. Faces is 13. So 0 divided by 13 will give you a 0 because we're doing integers. 1 divided by 13 will give you a 0, all the way up until we get 13 divided by 13, which will give you a 1. 14 divided by 13 will give you a 1, and it keeps going until we get to 26 divided by 13, which will give you a 2, etc. So when that happens, you can see that the suit is being filled into each card coming out of the array of cards called deck. So that makes our 52 cards. Next, the program has to shuffle the cards. How are we going to do that? I'm going to pull up the whole program here for a moment just to keep us on track. So before I show you how to randomize or shuffle the deck, let me just go over the whole program for a moment again. So remember we had cards is 52 and faces is 13. I declared my card structure. That's the card structure definition. I did a type def so I could create a card just by saying card. Have some function prototypes that get declared. And here I made a array of card structures called a deck. And then I got ready to give values to each one of my 52 card structures in the array by first creating the 13 faces and the 4 suites. And then we looked at the function that puts values for each card structure's members. So that's its suite and its face. We looked at how that was done. And now it's time to shuffle the cards. So in the main calling program, well, first I'll just use the srand to get my random number. Then I make the deck of cards by calling the fill deck function. And my next function that I want to call is shuffle the deck. And then deals all 52 cards, but really it's just printing all 52 cards out in random order just so that you can see that it works. So right now we're at the shuffle the card function. Of course we already set up so that we can use our random number, and let's look at the shuffle the card function and look at what's happening for it. So here's the function that shuffles the card. It's expecting to get a pointer to an array of cards, an array of card structures, which we call deck. And this is what it does. So there's a for loop, which goes through 52 times, 0 through 51. Here we create, well, they use size t. I would have used int because then I don't have to compile with the dash, with the dash standard equals C99. I would have said int j. Get a random, pick one of the cards at random. So this is random numbers between 0 and 51. So it's going to pick a card at random. That's card element j. Well, it's going to pick a number j at random between 0 and 51. And then I'm going to establish a temporary card which will be the first card number 0 in the deck. Will be the temporary card, and then it says get the random number, the jth number, out of the deck. So I get the jth card out of the deck and I put it in position 0 right here on this line. So remember, we're going 0 is the first time through the loop. And then I get the temporary card, whichever one was pulled by this j number up here by the call to the random function. I get the temporary card and put it into position j. So first I get the 0th card, put it into temporary. Then I get the jth card, which is random, put it into position 0. Then I get the temporary card, which was the 0th card, and put it into the J position. Then the for loop will repeat now in the position 1. So now I is 1. I pull a random number. Again, pull some random number. Put card position 1 into temporary. Get random card position J with a new random number. Put it in position 1. Get the temporary card, which was the one in position 1, and put it in position J. So that's how it shuffles the card. Kind of cute. Sophisticated. Back to the main program. Back up in here in main, I created the deck of cards, fill deck. I randomized them right here, and then the last function says to deal the 52 cards. So let's look at what deal cards does. So the deal cards function is expecting to get a pointer to the array of deck of cards. And see how we call it. We call it with just a deck of cards. That's great. So that's what it's expecting to get passed to it, and then it looks like it just goes through the 52 cards, which have been randomized, and prints out their face and their sweep value. And the result looks like, well, I compiled it. The result is here. Just all the cards in random order printed in this manner. Sorry, it goes off the screen here, but yes, program works. I should mention this last little piece of the printf statement is just to control putting out, looks like 4 cards at a time on a row before you get a new line. So that's just controlling this the spacing of the print statement. Well, wow, I've just spent 37 minutes just to tell you about a structure, which is only the first concept in this chapter. So I think that maybe there was so much in this example that maybe we should just spend this week's homework on a structure, and then there's only left some, well, bitwise, and then unions and enumerations are also in this chapter. And then the next chapter we need to learn how to read and write to and from files. So I need to space these topics out through the last few weeks, and I know we're all a little weak on the pointers aspect, so I think maybe we'll just get a homework problem on pointers and structures for this week. Okay, bye now.